This is question 1 in homework 10. The first question is about person process, and person process has xt equals to x0 equals to 0, xt1 minus xt2 equals to the number of events happening in time duration between t1 t2, and we know the probability of the event happens k time equals to this, and the mean of this process is the lambda t. The autocorrelation function is this, and the variance is lambda t. So this process is a function of the events and time. So we see the mean and the variance both are a function of t. This is reasonable for a long time t, and the time is longer, the more events like to be happen, and the variance goes larger. And the second one is person increment. This is firstly we have a person process xt. Then we define yt equals to this, and the probability of yt equals to this. So we get the mean of yt is lambda. The autocorrelation function depends on epsilon and the difference between t1 and t2, and we get the variance is also dependent on the epsilon and the difference between t1 and t2. This process presents a discrement of a person process in a unit time. We see that the mean is lambda, which means person increment is lambda, no matter how long is epsilon, and this is reasonable. As for autocorrelation function, when the difference is larger than the epsilon, the function should have no elements of epsilon, which means the epsilon will not affect the autocorrelation function. And when the difference is smaller than epsilon, this means epsilon and the difference of time should affect the autocorrelation function. Then about third question about Poisson impulse, and this process is a limit format of Poisson increment, so we can get some parameter from the former process, like the mean of the Poisson impulse is lambda. The autocorrelation function is lambda squared plus lambda times the impulse function, and the variance is lambda times the impulse function. Then about the semi-random telegraph signal. So we define xt equals to 1 when k is even in the time duration, and -1 when k is an odd number in time duration. And we define x0 equals to 1, and the probability of events happens k times equals to this, and we get the mean of this process is e to the power minus 2 pi t, and the autocorrelation function is e to the power minus 2 pi times the absolute value of difference between t1 and t2. So we see that the mean is e to the power minus 2 pi t, and this means when t goes to infinity, the mean is 0, and this is reasonable because the telegraph signal has the same probability goes to 1 and -1, so the mean of the total signal should be 0. And as for the fifth question about random telegraph signal. So we define random variable a, and the probability of a equals to 1 equals to the probability of a equals to minus 1. Both are 1/2, and we define yt equals to a times xt, where xt is semi-random telegraph signal. So we get the mean of yt is 0, and the autocorrelation function is the same as a semi-random telegraph signal. So as in this difference between the random and semi-random telegraph signal is x0 equals to 1, but yt could be either 1 or minus 1. And this difference lead mean of the random telegraph signal is 0 because we don't need infinite experiment time to cover x0 equals to 1. As for the sixth question about random walk, so we define xt equals to x of nt equals to the 2k minus n times s, where s is a step, and we know the probability of x of nt equals to rs, and we get the mean of random walk is 0, because here we get use the probability of go forward and backward, both are 1/2, and the correlation function is the mean between m and n times s squared. So here we have a large n, and the absolute value of k minus np is of order root square of np2. We can easily calculate the probability of n of x and t equals to rs. This process means we have probability p to forward as step, and probability q equals to 1 minus p backwards. So for the mean equals to 0, we consider p equals to q equals to 1/2, and we always can be at original point in the future, and this could be reasonable. And for the seventh question about Wiener process, so we define this process Wt is the limit of a random walk where s goes to 0, t goes to 0, and n goes to infinity. So we get the second moment of Wt is alpha t, where alpha is the limit of s squared divided by t. We can get the probability function and the density function. We get the mean of Wiener process is 0. The autocorrelation function is mean between t1 t2 times alpha. So here we know that Wiener process is the limit format of random walk. Thus, we also express some characteristics of it, which is the mean is 0, and autocorrelation function is the limit of the autocorrelation function of the random walk. So we get result is the mean between t1 t2 times alpha.